So again, solving for this one here. This one we can solve for all real numbers. So we're going to have to use a period for this one. So we have to make note of this horizontal compression that we have on this graph. Okay, just going to mark that. Now, when we do this, we can't solve this with sines and coses. Okay, that's not possible. We need to convert this into one sine or cosine function. In this case here, we have to recognize that this is actually an identity. And the identity is, when we move this out, I'm going to factor the 2 out, and it's 2 sine 3x cos 3x. Okay, and I'm just going to make that -1 on this side. But what's happening here is this is actually an identity. Okay, and if it's hard to see, I'm going to rewrite that identity. We often see it like this: sine 2 sine alpha cos alpha, and that's equal to sine 2 alpha. Okay, so this is an identity. So I'm going to convert that into 2 times, and I'm going to change that identity into sine of 2 alpha. Well, alpha is not alpha, it is 3x. So it's doubling 3x, and I get 6x. So remember that this is a double angle identity and not a 2 theta identity or 2 alpha identity. It's double. It's just whatever the angle is, we double it. So once we have that, we can then solve for sine. So I get sine 6x, and that's going to equal -1/2. That's an exact value, so then I need to find where that is in my circle. So I'm going to draw my circle out here. So -1/2 is going to be in these quadrants down here, and down here. Okay, those are my two positions of -1 over 2. The angle 6x. So remember, I'm solving for 6x. That one of them is going to be -pi over 6. Okay, and the other one, I'm going to call that theta 2. The other one is maybe I'll do these in different colors here. Okay, so I'm just going to color code these. So this one over here, that one is going to be the one I'm going to call theta 1. That's going to be at -pi over 6. And then we'll have another one over here, the one in quadrant 3. We're going to call that theta 2, and that's going to be 7 pi over 6. Okay, so those are two positions that we have. We could maybe put this in the same period. So I'm going to convert that first one into a positive angle, into 11 pi over 6, and then we can solve for x. I need a little bit of space. I'm going to have to zoom in. Solving for x, we're going to divide by 6. So I'm going to end up with, actually, let me just organize this a little bit better so it's a little bit easier to see. I'm just going to shift this up a little bit. Give myself a little bit of space. Okay, so if I solve for this x here, I'm going to end up with 11 pi over 36. When I need to divide both sides by 6, I'm going to do the same thing over here. I need to actually still solve for x. So solving for x, I end up with 7 pi over 36. So those are my two solutions. Okay, that's those two solutions in one period. But now I have to account for the fact that there is this horizontal compression going on here. Okay, so this horizontal compression of 3. Oh, sorry, that's not 3. The horizontal compression is 6. Okay, so just ignore that first part. The horizontal compression is not 3. We have to base our horizontal compression on the equation we solved. So if the horizontal compression is 6, then the period is going to be 2 pi over 6, okay, which is basically going to simplify to pi over 3. So these solutions are going to repeat itself every pi over 3. And it's basically 2 pi over 6 simplified, and divide by 6 because it's a horizontal compression by 6. So same thing over here. The period is going to be pi over 3. So then the solutions are going to repeat themselves every pi over 3. So I need n pi over 3. Okay, just make that a little bit nicer looking. That's 7 pi over 36 plus n pi over 3, and 11 pi over 36 plus n pi over 3. Okay, so the last one here is we need to come up with a sign equation for this. Now we talked a little bit about the different parameters up here, calculating a, b, c, d, and t. And we need those parts to be able to write the equation for this. So I've kind of summarized it down here. To calculate a, we have a amplitude is a distance between the middle to the top. So we want to find the distance from the top to the bottom. So y max minus y min, take the absolute value and divide it by 2. The d value is going to be the middle position. Well, if I want to find position, I find the average position. So I find the average value of the max and min of y. The period is going to be a distance. So again, I'm going to subtract to get distance and take the absolute value. The distance between the max and min, okay, this distance here between the max and min is half the period. So I take that distance, I double it. The b value is when I take the 2 pi divided by the t that I've calculated. And for cosine, and it's usually cosine is going to be the easiest. So in this case, it says find a sine equation, but cosine would be the easiest. And we just take the x coordinate of the max, and that is our horizontal shift because that's our start point. Okay, so let's go ahead and do this. So I want to find my a value. Okay, the a value is going to be the half the distance from the top to the bottom. So it's going to be -4 minus 2, which is 6. Take half of that distance, I get an amplitude of 3. The d value is going to be the average position of the top and bottom, so -4 and +2. It's +2. Okay, and half of that is going to give me the middle position of -1. So I can see very clearly that -1 represents my middle position. My period, I'm going to double the distance between the min and the max. So 13 pi over 12 minus 7 pi over 12. Okay, taking that calculation, that's going to be 4 pi over 12 times 2, which is 8 pi over 12. And that simplifies to 2 pi over 3. That makes the b value, my compression factor, 2 pi over 2 pi over 3. And that just gives me a horizontal compression factor of 3. Okay, so writing my equation out now, I'm going to do this with cosine first, and then we'll figure out the sine. So cosine is going to be the easier one. So it's going to be 3 cosine b value of 3. The horizontal shift is going to be 7 pi over 12. And then the vertical shift is -1. So there's my cosine value. there's a cosine equation here. Okay, I'm just going to highlight that. There's a cosine version of this. I'll also do a sine version of this. It's really going to be the same thing. The only difference is going to be the horizontal shift. So everything else is the same, but we just have to figure out the horizontal shift. Okay, there's a few different ways to do this, but basically we're trying to find the location of that point. And that's basically 1/4 of a period from that maximum point. So if I calculate 1/4 of a period, well, period is 2 pi over 3. And if I want 1/4 of that, I get 2 pi over 12, which simplifies to pi over 6. So the location of that, the horizontal location of that is pi over 6. Okay, sorry, that's that's not the location. Sorry, my mistake. We have to be very careful about the position versus distance. So this is a distance of pi over 6. And so from here, that distance is pi over 6 between that point. So to find the location of that, I'm going to take 7 pi over 12. I'm going to write this as 2 pi over 12 since I want a common denominator. So I'm going to start at 7 pi over 12 and go backwards 2 pi over 12. So that position is 5 pi over 12. Okay, so there's lots of different ways to do this, but the way I did it was I found a quarter period and I worked backwards from that position, 1/4 period, which is pi over 6. And again, since we're going to subtract that to pi over 12, a pi over 12 fraction, I'm going to leave that as 2 pi over 12. And that gives me the distance between the max and the middle. And that represents 1/4 period. Okay, so I'm going to just maybe say here, this represents 1/4 of the period. And this is what I'm using to calculate this position in here.